Well, hello. I'm here on a Saturday morning. My name is Jay McCoy, and this is going to be my video presentation on the movement of a lipid, protein, and intracellular protein. Okay, we'll dive into what those are in just a second. Before, here is my name and the date. Okay. All right. So I've created a visual description. Illustration per se of the movement of testosterone, collagen, and actin. Alright, testosterone is my lipid, collagen is my protein, and actin is my intracellular protein. Okay? So if you look closely, you have the big outline of a cell, you have a lipid pathway, you have a protein pathway, and you have a intracellular protein pathway. Okay. First, let's start with the lipid. Okay. So it starts as cholesterol. Testosterone starts as cholesterol on the outside of the cell, and through cell receptor mediated endocytosis, it is brought within the cell as lipid droplets. From there, it is metabolized and transitioned over to the mitochondria. And in the mitochondria, it is converted to and I will most likely butcher this, pregnenolone. All right, and then pregnenolone is then transported through vesicles to the SER, which is the smooth endoplasmic reticulum, and from there it is converted to testosterone. All right, and since testosterone is lipid soluble, it can easily diffuse through the plasma membrane out into the bloodstream and perform the characteristics that testosterone has, which is metabolism, development within our body, and it helps maintain homeostasis. All right, so let's transition to the protein. All right, a protein is collagen. Collagen is a vital function for multiple reasons, but first let's start where it starts. So it starts in the nucleus. All right, so it goes from the nucleus through transcription, and it gets exited from the nucleus through nuclear pores to the cytoplasm, and then in the cytoplasm it goes to the rough endoplasmic reticulum, which is taken within by ribosomes, either free or ones attached to the RER, and goes through translation. All right. Then after translation, it is a precursor called pre-pro collagen. All right, pre-pro collagen is thus transported to the Golgi, and through Golgi apparatus, it goes through a series of reactions per se, and is secreted and transported through secretory vesicles. Yeah, secretory vesicles to the plasma membrane, and then from the plasma membrane, it is exited the cell via exocytosis, and then put into the extracellular space, which is outside of our cells. And once it's outside of our cells, it goes through like a little cleavage process. After that cleavage process, it turns into procollagen, and then after procollagen, it then gets cleaved again into collagen. Okay, and you can kind of see. I'll get this a little bit closer. Goes nucleus, and there's a line. Got this straw here to help. Nucleus strand. mRNA strand gets put down to ribosomes, free, and part of the RER, and then it goes all the way to Golgi, and then outside of the cell. Okay? Alright, now let's transition to, see if I can get this up, intracellular protein pathway, which is actin. So actin is a intracellular protein. Starts in the same area, the nucleus. Is the nuclear DNA strand above what we just did for collagen. So you see the long arrow gets transitioned, exits the nuclear pores, gets transitioned to free ribosomes, and when it hits the free ribosomes, it gets translated into, it goes through a translation process. Let me backtrack. Starts as transcription in the nucleus, leaves through the nuclear pores as an mRNA strand, and then that strand gets translated by the ribosomes. proteins. Okay, and then it is put into the cytosol, and in the cytosol, it then performs vital functions within our cells. It never exits the cell; it stays within our cell. It performs things such as cell shape, facilitates the intracellular transport within the cell, also assists with movement of sorts within the cell. So it is important within the cell. It forms these little elements, helps keep the cell strong, usually stays on the outside, the inside of the cell, with the outside part of it, and it's vital. So those are the 3 protein pathways. Apologies if it's a little windy here. It's unfortunately the best I could do, but this is the movement of a lipid protein and intracellular protein. I hope you guys enjoy. Take care. Thanks for your time. Appreciate it.